My name is Domenico D'Astoli. I'm part of the business unit in Cisco, which is responsible for ACI. I'm a technical marketing engineer, and I'm based out of Belgium. Sometimes when I'm in US, I make some jokes about I'm in Brussels, and someone I think I'm in Brazil. Sounds kind of similar, but it's not. But you know, obviously, because you're from Europe. Today we're going to talk about mastering ACI and OpenStack, right? So this is an advanced session. We're going to go together through some, highlight and overview about what we're going to talk about. But then we're going to deep dive, and hopefully we're going to get to the level that you expect about this session. So what is the agenda? We're going to have an overview of very quick overview about OpenStack, what it is, what are the components, and when you integrate with ACI, which components indeed we are touching with the ACI integration. So we're going to see the general challenges of OpenStack when you deploy an OpenStack setup that you may have, and how ACI can improve or can solve those challenges for you. So in fact, we're going to deep dive through the unified ACI plugin for OpenStack, talking about how you install it, what are the components, and eventually what are the network benefits that we have there. So that's going to conclude the first part of the presentation. I'm going to have some live demo here. Hopefully it's going to be better than this morning demo. I'm not sure some of you, I think, were following the OpenShift session I had in the morning. It was not that successful. Live demo always are a bit tricky, but yeah, I'm sure it's going to go better. So after that, we're going to have some deep dive into operational items with OpenStack and the ACI plugin. So we're going to see how you do basic things like creating tenants, but also other things like external connectivity, adding other workloads to an OpenStack environment like virtual machine, bare metal, and so on. And we're going to also have some view at the VNF integration, so some what we call neutron SVI function that we have with the OpenStack plugin in ACI. So ACI and OpenStack. OpenStack, if you are here, you are very numerous, is because OpenStack is indeed a very interesting cloud operating system that is capable to manage the networking, the compute, the storage, right? So it manages all these things for you. And it's a project which was initiated a few years ago, 2010. It was initially a NASA project, and then it was eventually donated to the OpenStack Foundation. So it's a completely open source foundation, which from 2012 eventually is collecting a lot of developers which are all contributing to the code, right? So there are almost 200 countries around the world with hundreds of thousands of developers that are working in this project. Right, so very, very interesting. And we see OpenStack, well, you're probably from different kind of business, but we see OpenStack deployed in many different type of environments. So we see for telco cloud use case, maybe we see in enterprise customers, we see in service provider, so it's used for public cloud or private cloud, kind of different solution. Right, so the OpenStack is coming with a number of projects. I assume that you know them very well, better than me maybe. So we have got things like Horizon, which is the typical portal to interact with an OpenStack solution. You've got things like Glance to manage your images, Nova to manage your compute nodes, right? And then there's Neutron. So Neutron is the component in OpenStack which is responsible to create the networks, the virtual networks eventually presented to your workloads, to your compute virtual machines, and eventually to make them interacting with each other, interacting with the rest of the world. So we're going to spend most of the time today, if not all the time, talking about the Neutron component, because this is the one where we are developing a plugin for the ACI SDN integration. So talking about Neutron, in fact, I guess some of you have been at the OpenStack Summit. I recognize some face, the last one at least in Berlin. I think in general, you see and you hear recurrent feedback from customers or users complaining about a few things in Neutron, right? So one of the things is that, at least by default, Neutron does not offer a really distributed routing or L3 advanced kind of function, right? I'm talking about not only routing, but also NAT, FIP, metadata, and all these things, right? So you typically need some Neutron or network nodes where you also trombone the traffic, right? And then eventually you have the traffic routing wherever it needs to go. Also from performance perspective, coming from the fact also that distribution is not there, but as well performance perspective, being typically OpenStack a virtual solution, so the virtual router function is not providing the right level of bandwidth or low-level latency that you require in order to make communication of your virtual world from an OpenStack perspective and the rest of the world, meaning other workloads or maybe the external networks that you have. And then again, visibility from an operational standpoint. So underlay and overlay are typically quite, two different aspects from operation and troubleshooting perspective. So it's through some sort of integration, right? So OpenStack can pilot some way your switching layer, but it doesn't really have visibility about what's going on, where the virtual machine are attached into your switching layer environment, how the traffic is flowing, how it goes out to the network, right? So visibility is a bit of a challenge, and with that comes as well the complexity of troubleshooting, obviously. So to resolve, if you've got problems, how do I start? Where do I start? Do I involve networking guys that don't know about OpenStack, or I talk with OpenStack guys that don't know about the networks? It's hard to combine and make an effective and efficient way of troubleshooting. So indeed, why ACI and OpenStack? ACI provides what we call the unified plugin. We're going to see what it is, right? But the intent is basically to try to solve these 4 challenges. So one is from as we were saying, distributing or replacing completely the data path from Neutron perspective by having a distributed routing function that will also have capabilities of doing distributed NAT function, but as well metadata and the HCP information that can be done directly in the host. So you never need to go outside of the host to gather or to get this function enabled. And then from hardware acceleration performance, ACI provides by itself VXLAN encapsulation. So no matter if you have VLAN or VXLAN from the compute node to the top of the rack switch, then ACI will do a VXLAN encapsulation for you. Right, so you can choose and pick what encapsulation you have between the compute node and the top of the rack switch. That may depending on the NIC, the physical NIC. Is it supporting VXLAN offload or not? Right, so you can choose whatever you want, but you be sure that VXLAN is going to be the scalability that you have, because ACI can scale VXLAN internally, and therefore it has a sort of what we call per port VLAN significance in the ACI leaf nodes. As well, we're going to see a few other things, like from performance perspective. With the plugin, we support things like SROV, OVS DPTK. We've got also VPP, which some of you maybe know. It's a vector packet processing protocol, and that's something in the roadmap that is coming in the second quarter, in the second semester this calendar year. And then VNFs. For VNFs, we've got a few functions which are specifically for VNFs. Maybe some of you are interested in 5G, maybe telco cloud or other solution where you need to have VNFs there. So with the ACI unified plugin, you can have 64-way BGP, dynamic routing peering protocol, automatically provision for you. And we'll see that in detail, right? So all these things is just an integration. We'll deep dive in each of those topics. Integrated overlay and underlay. Why that? Because when you do the ACI integration, ACI will expose in the graphical user interface the objects which are created in OpenStack. So things like the virtual machine, obviously, the nodes that you have in your OpenStack deployment, right, and the external connectivity. All these things will be exposed in ACI. So the visibility that you have in terms of where my VM is running, to which server is it bound, to which NIC of the leaf is connected to, and so on and so forth, right? So you'll have all this information at glance. And as well, for you that you know the health score mechanism in ACI, right, that number in percentage of how much is healthy my system, you know, the OpenStack integration will report also to the same health score mechanism, so you can have one single pane of view of the overall solution of the overall architecture of an ACI plus OpenStack integration. So at the end of the day, what is it, this solution? How do we do this with ACI? Well, with ACI, indeed, we have this concept of unified plugin. So the unified plugin, as we will see, is an ML2 plugin, the modular layer 2 plugin provided for the Neutron OpenStack project. And what are the benefits of that? As we said, all what we mentioned before, but as well, it integrates, you know, OpenStack as one of the possible workloads that you have in your ACI system. So that means that once OpenStack becomes, you know, visible as endpoints and endpoint groups, you will be easily interconnect potentially your OpenStack workloads to any other workloads. And you may know that from VMM integration perspective, we do integrate with a bunch of things, right? OpenShift we mentioned this morning for who was at the session, Kubernetes, but also VMware, SCVMM, and so on, right? So, you know, it's quite a large way of doing integration with multiple different kind of virtualization and containerization, and also bare metal kind of server and workloads. So as I said, ACI Unified plugin is just an ML2 plugin, right? Why do we call it unified? That's an historical thing. So for you guys that have been working already with the plugin for a while, sometimes ago we used to have two different plugins. One was called ML2 plugin, one was called the GBP plugin. I'll explain that in detail in a few slides. Now we only have one single plugin. It's called Unified plugin, right? So we made it simpler, but under the hood, it's an ML2 plugin, right? So Neutron allows different vendors to attach, to plug their SDN kind of solution to the OpenStack through an ML2 framework, right? The modular layer 2 framework. So any vendor could potentially develop their own framework. ACI, Cisco ACI engineering team developed this unified plugin, right? So the unified plugin, or in general ML2, typically they have two components, the type driver and the mechanism driver. So with OpenStack ACI unified plugin, we use the OffFlex type driver, and we'll understand why. And the mechanism driver is the APIC AIM. Why APIC AIM? Because Neutron talks to the APIC controller, right? It uses RESTful API in order to deploy policy and then obviously configure things, as we will see during the course of the session. So what are the options when you are developing, you're doing this kind of integration? Two options. As I mentioned before, between the OpenStack compute node and ACI, you can choose a default model, either VLAN or VXLAN. Potentially, you can combine both of them, also using hierarchical port binding. We'll see later, right? But at the installation step, you typically decide, do I want to use VLAN or VXLAN just between my compute node and the top of the rack switch? And then the second thing that the unified plugin allows you to do is to use two different models, two different ways of operating your environment. You can operate in the standard Neutron API way, right? If you've been playing with OpenStack, which I'm sure you did, that means creating Neutron networks, Neutron security groups, Neutron subnets, Neutron whatever, using standard API. You can keep using that, right? So it means that even if you integrate with ACI, the operational model doesn't change. You keep using the same operational way you were doing things as before. Or you can use a group-based policy mode. I'll talk about it a bit more in detail in a few slides, right? It's a new project which was developed by Cisco, but it's open source. So it's a sort of way of abstracting the application layer from the networking layer. Again, just bear with me a few more slides and I'll tell to you a bit more in details. So how do I install this thing, right? From an installation perspective, we do provide guidelines. They are on cisco.com. So typically, we support Canonical, Red Hat, OpenStack distribution, and as well Cisco Vim. For who doesn't know, Cisco Vim is also a Cisco OpenStack solution based on Red Hat OpenStack, right? So we do support these three solutions. It's an open source plugin, though, so we publish the plugin in GitHub, so potentially you can use and consume by yourself, installing in other distributions. We know, for example, that SUSE is using this plugin as well. Obviously, from a production perspective and supporting something that you download and you operate from open source standpoint, it's obviously having some kind of challenges, but this is possible, right? So you can do so. And potentially, if you want to run the GitHub, so the upstream plugin, you can do so. And there is some GitHub documentation you can follow also to have that running in your whatever OpenStack distribution you're running. In terms of scalability, I put here a slide, but numbers keep increasing. It's just to give you an idea here, right? So we are talking about 2,000 endpoints, so 2,000 virtual machine per leaf pair. So you typically have compute nodes attached in VPC mode to a pair of leaf switches, right? So these numbers are keeping on being updated, right? And they are in the release notes that we have for each release. Now it's 2,000, just to tell you, in the H release. In the next ACI release, it's going to be 4,000. By the end of the year, we plan to go to 10,000, right? So we are keeping increasing those numbers. And obviously, I've got already some feedback of customers that want to have more and more, right? So please reach out to us, and we can work to increase those numbers as you need. While you are installing the ACI Unified plugin for OpenStack, a consideration to be taken care of, multipod is supported. So you can potentially have OpenStack nodes distributed in multiple pods. That's completely transparent from an OpenStack installation perspective. Actually, there is also some white paper which I posted, right, describing this kind of solution, I think on cisco.com. You can Google for it, or I can write in WebEx team later. So multipod supported. You can have, if you're not familiar with, multipod is a way of having multiple ACI fabrics connected to each other through an IP network, right? And they share one single AP controller cluster. Another possibility also, you can have multiple OpenStack cluster, which are all attached to the same ACI fabric. I have in my lab, I have 2 or 3, right? So if you run one OpenStack environment for your production, pre-production, etc., you can do so. So we are not binding to only one OpenStack integration with ACI. You can have multiple, right, OpenStack and still one ACI fabric. Right? Yeah, one question? The question is, what about multi-site? Multi-site is another type of ACI extension, if you will. And the idea there is that you have ACI fabric with independent AP clusters, right, which are handling those sites. And then you have one orchestrator on top of it. It's called MSO, multi-site controller, where you distribute the policy. Now, in the multi-site use case, typically the idea is that you have got isolated or independent VMM domain. So that means that the OpenStack cluster, typically in that kind of design, are bound to one single site, right? We have some, if you are interested in that use case, we can talk about it later. I have some demo video lab where you can do some communication across sites, between different OpenStack clusters. But you cannot stretch clusters across multi-site because of the design of multi-site itself. If you have, any specific use case about things, please come and talk to me, and we can obviously see what we can do. What are the components of this solution? So the components of the unified plugin, once you install it, so we have seen that there is some documentation to do the installation. Typically, we support OSP Director, for example, or canonical Juju Charms, as I said. So when you run the installation, you just add some YAML configuration information in order to deploy the unified plugin. You don't need to do manual things, right? It's fully supported by the installation tool. So you install your OpenStack. OpenStack comes with the unified ACI plugin. What are the components that you will see there different from a normal standard OpenStack installation? I list here 5 components, right, at a high level. So you have got the ACI ML2 plugin, right, so the unified plugin, which is installed in the controller, obviously. In the controller, you also have one daemon. It's called the ACI integration module, AIM. Then you're going to have, that is an optional thing, and we'll see why and what are the options there. You've got optionally an OFlex agent, which is running in the compute nodes. So you can have the compute nodes having this OFlex agent or not. Then from an ACI standpoint, you've got 2 elements, the VMM and the APIC model, so the VMM manager running in the APIC controller, and then the OFlex proxy function, which is on the leaf switches, on the top of the rack switches of ACI. What is the ACI integration module, right? So the ACI integration module was that little thing, that process running in the compute node, in the controller node from an OpenStack standpoint. So the ACI integration module is the controller, basically, which is responsible to make RESTful API towards API controller. So it's basically taking the rules, the policy, which are provisioned from Neutron server and translated with the ML2 plugin, the unified plugin. And then it's basically putting those policy into the AIM database. The AIM database is an extension of Neutron database. And it's pushing RESTful API call to the API controller. Another function which it's doing, it's basically using a webhook on the objects that it creates on ACI. And at any point in time, it makes sure that the synchronization is always correct. So it makes sure that there is no kind of misconfiguration. So if you change something in ACI, it will push it back, and it will make sure that that configuration is aligned between the database running in OpenStack and the ACI view from a configuration standpoint. In just a slight change for who is running or has been running OpenStack, in OSP 12 and 13 from Red Hat standpoint, as you may know, they went for a containerized kind of model. So they containerize things, and we also containerize the ACI integration module. So before this release, we were running AIM as a daemon, as a process. Now it's running its own container, right? So you can see this is the controller in an OpenStack distribution. You can see Docker, and you'll see the container running there for the Cisco ACI AIM Docker container. Right, so it's running by the way in host mode, this specific container, right? So what is the model? What is the workflow with the ACI integration module? As I told you, well, OpenStack is a cloud operating system, right? So it's an orchestrator which orchestrates compute, storage, network. So the idea is that we want to keep, the OpenStack administrator orchestrating all of this. So the idea is that it will still insist on, Neutron and Nova in order to create Neutron network and Nova compute workloads. And it will create objects here. So under the hood, AIM, the ACI integration module, will take care of pushing policy towards ACI, the AP controller. Right, so in the moment where the OpenStack administrator creates things, Neutron networks, Neutron routers, Neutron security groups, those will be created as RESTful API call as objects in ACI. We'll see the mapping, in a couple of slides. By the end of the day, there's going to be things like endpoint groups, contracts, bridge domain, and things like this created on ACI side. So when you instantiate virtual machine, you bind them to a Neutron network, right? What will happen is that from ACI standpoint, we're going to push the policy. So the AP controller will push the policy to the ACI fabric to make sure that the right function from a contract perspective, from VLAN or VXLAN encapsulation are all provisioned, and then the virtual machine are getting the right path and configuration to communicate with the rest of the data center. So now the thing is, in Neutron, I think it's quite normal, right? So the OpenStack administrator will configure certain things in AIM, but what if you need to configure other things which are more proper of the ACI objects? I'm talking about, I don't know, typical example, a bridge domain flooding mode, or a bridge domain limit IP learning on subnet, or things like this, right? Certain attributes which can be specific to APIC resources. Well, for that, you have a new tool. Well, you have a tool provided by the unified plugin installation, which is called AIM Controller CLI, right? So you can run this CLI. The CLI function are basically in order to query from a controller OpenStack perspective, what are the resources in ACI. So you can query what are the objects in ACI existing there. You can ask for details about those resources, and you can update objects. So here I'm just giving you a brief example of, I've got a bridge domain, and I want to influence how that is configured, right? So in the AIM controller, I run the bridge domain find, so I know that ACI has 1, 2, 3, 4, 5 in this case, 5 bridge domains existing there in different tenants, right? So I select mine. I'm interested in one which is the PRJ B7 blah, 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 yada, 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 right? So in this case, I run the show command. So I know all the details, all the attributes that ACI has about this bridge domain. And maybe this limit hyperlearning to subnets I want to change from true to false. So I just run the commands AIMCTL controller, I update the command, and I pass the new parameters false. Right, so the results is going to be visible in ACI as well. Right, so ACI, AIM controller is usable for things which are not directly controllable from a Neutron API call perspective. Now I'll tell you a little secret. In general, well, not really a secret, but a tip or recommendation, I would say. So AIMCTL controller should be used minimally. I mean, you typically don't want to use a CLI, you want to use just API from Neutron perspective. So we try, from a Neutron perspective, to import at least the most used function in order to have whatever objects in ACI changed in the attributes. Some are missing. So if you have got use cases, I know there's someone in the room who has got already some use cases. So we'll try to implement those directly in a Neutron API call, so to make it easier, from a controller perspective. Yeah, one question. Yeah, the question is, what is the difference between GBP, ML2, or AIM controller? GBP and ML2 we'll see in a second, probably is in a couple of slides from now. The AIM controller is just a tool to query the ACI database from a controller perspective in OpenStack and make sure that you have the right view, and eventually you can you can change attributes in the APIC configuration if you like to, right? So you can use this AIM controller. I gave you an example, right? So the BD settings you cannot influence neither with GBP nor with ML2. So you need to use this AIM controller, and the AIM controller can be used in any mode, both GBP and ML2. And we'll see in a second what they are. I hope. Did I confuse you or? Okay. What is the second? So AIM controller, or AIM daemon, which now runs as a container, right? So that's a fundamental thing. The second is the Neutron OFlex and Neutron OFlex, the Neutron OFlex agent and the OFlex agents. Those are two things which are running optionally in the compute nodes. Again, these are containerized right now. I put this slide on just to show you a bit more in detail what they are doing. So if you decide to install the OFlex agents in the nodes, basically what's going to happen is that Neutron server will talk with the Neutron OFlex agent, right? This agent running in the compute node. The OFlex agent will create a file, an endpoint file, and I'll show you, in a second what it is, where you have basically information about all the virtual machine that has been created in that specific compute node. With this information, so the endpoint files and also the information coming from ACI, driven by OFlex protocol, will create obvious Open vSwitch rules through OpenFlow, right? So Neutron server tells OFlex agent what are the VM created there, and eventually what are some objects created from Neutron perspective, and endpoint files will be created. The endpoint files will look something like this. So each compute node will have one endpoint file per virtual machine created. With all the information here, it's just wrap up because it was too long. But the idea is you have all the information about the VM, the IP address, if it has a floating IP, what are the security group applied to that VM, and so on and so forth, right? So with this data plus the OFlex policy enforced by the API controller, then we'll create Open vSwitch rules in the compute node. So the Open vSwitch will be capable of running the right security enforcement based on the policy downloaded in this way. Yeah? Makes sense? So let's see the overall picture once again. What's going to happen? Typically, the OpenStack administrator will talk to the Neutron server, so Neutron API or GBP API, we'll see. And these calls will be translated with the ML2 plugin to ACI integration module. The ACI integration module is responsible to make RESTful API call to the API controller. So tell the API controller, I've got these networks, I've got these security groups, I've got these VMs, right? Make sure all is properly configured. And then the API controller instructs the proxy switches that you have, so the OFlex proxy, so that each compute nodes connected to the OFlex proxy layer is capable of downloading the right rules and then enforcing those rules at the Open vSwitch level. Yeah? Question here? Make sense? Seems complicated, but it's all automated. It's all done automatically by the tool for you, right? So you don't need to take care about anything, but just configuring your neutron policy. So I said that the neutron OpFlex is actually optional. What happens if you don't install the OpFlex agent? Well, first of all, why wouldn't you install the OpFlex agent? Well, the OpFlex agent may not be installed in scenarios like you're running SROV or OVS DPDK. If you are running SROV or OVS DPDK, well, in SROV use case, you don't have OVS at all, right? So the VM is directly plugged in into your physical NIC, so you don't have OVS. You don't need for any rules provision there at the host. OVS DPDK we do support, but we do support without OpFlex mode, right? So in these two cases, for example, you may not have the OpFlex agent running there. So how will it work? It's slightly different from the previous slide, right? So the idea here is that, again, the Neutron server will instruct AIM controller, so the ACI integration module, and this will create, again, the tenants, the EPGs, the bridge domain, and all these things. But in this case, we don't have any OpFlex policy rules provisioned to the host. So how does the OpenV switch have, the right policy enforcement? Well, you're using the standard Neutron agent OVS, right? So the Neutron server will talk with the Neutron agent OVS and will program eventually the policy directly, right? So this is the model where you don't have OpFlex agent. What you lose and what you gain if you have OpFlex or if you don't have OpFlex, then. So if you have OpFlex, you have things like distributed routing on the host. If you don't have OpFlex, the distributed routing will be done at the leaf, right? So to be routed, a virtual machine needs to get to the leaf directly connected, right? So that's obviously a better enforcement from OpFlex perspective. Also, distributing NATs is not possible without OpFlex. And other things like the ACP optimization, metadata, and as well, typically, so we use with the OpFlex OVS rules, otherwise OpenStack typically uses IP tables, right? So slight difference maybe in performance. Someone says OVS rules are a bit more performing than IP tables, right? The good thing is that if you've got, imagine you've got some nodes, and I know some customers has, some users have, some nodes with SROV function, some other with normal virtual machine. You can mix and match. You can have some nodes where you distribute OpFlex agents and some other where you don't. So you can also run these kind of scenarios. And potentially even within the same node, you can have SROV and OpFlex OVS, for example, right? So in these tables, I'm not going to go into each and every kind of cases, but you can have it there. You can download the slides, obviously, afterwards as well for your reference. Finally, the other two elements. We spoke about the ACI integration module, the ML2 plugin, and the OpFlex agents. The other two components, which I was talking to you before, are the ACI component running in the APIC controller, so the VMM manager. The VMM manager, if you're familiar with, is what is used also for any kind of VMM integration, VMware, SCVMM, Kubernetes, all what we have, and as well OpenStack, right? So VMM manager is the one responsible to create objects which are proper of the virtual machine manager integration that you're running. And then the OpFlex proxy, I spoke to you about the OpFlex proxy before, right? So it's the layer running in the switches. The reason why we have this OpFlex proxy is because we want to scale more, right? So we don't want the APIC controller to talk with each and every OpFlex compute nodes. So the OpFlex APIC will talk with the leaf switches, and then the leaf will distribute the policy in all the compute nodes directly connected, right? So you can scale more by distributing the policy on the leaf switches components. So from an ACI view, obviously all this VMM integration will bring to have more visibility. We'll see in the demo I'll run later. You'll see that you can have the neutral network will be visible, and as endpoint groups in ACI, you'll see the virtual machine appearing there as endpoints and so on. Right? So we'll have a lot of information. We'll have also obviously the overall, the global view of an OpenStack installation with what are the nodes deployed in my OpenStack installation, what are all the networks deployed in that OpenStack cluster, and so on. I want to talk to you a bit more about the OpenFlex integration. So OpenFlex is bringing quite a few benefits, right? So how does it work when we have OpenFlex there? So at the Open vSwitch layer, what do you do? Well, we actually create two bridges. So one bridge is called bridge int, and it's where the tap interfaces of the VM are directly plugged in. Then there's a QPF, QPI pair. That's one per VM that we create to maintain isolation of the flows. That goes to the BR fabric. Why do we have two OVS? Because of performance. We want to segregate different function done by different switches. So you're going to see OVS rules doing security enforcement at the BR int level, and then all the more advanced kind of routing function, and as well the VXLAN encapsulation to the uplink are done by the bridge fabric in this case. So by doing so, as I said, you're going to have distributed functions. So obviously all the routing between virtual machine is happening locally. If you've got different neutral networks in the node, you're going to see VM1 to VM2 or VM2 to VM3 in different subnets. They'll talk to each other. You can see, if you want, you can dig a little bit at the Open vSwitch rules provision to do that. You can log into your compute node and check the OFCTL commands to dump the flows that you enforce at the BR int level, right? So you will see indeed the right of the Open vSwitch enforcement that allows, or rather deny, traffic across different virtual machines. So again, you don't need a neutron or a network nodes. You will never need, as a typical, by default installation of OpenStack, typically to route traffic to your router's function and then go back to other virtual machine. That is removed. And then, obviously, the view that you have, so I guess from OpenStack perspective, right? So that's just a screenshot of horizon view. You have, the different networks will be visible from ACI perspective as, this diagram with your network, the other network, and the router. So you have, a kind of really one-to-one mapping of the different views. We're going to talk later a bit more extensively about the L3 out, so the external definition or extension, right? So how do we do there? If you want to use, for example, more advanced things like SNAT or floating IP address assigned to a VM, what we do, we effectively create another kind of layer, another subnet for SNAT or floating IP addresses. And that's going to be provisioned as well in the Open vSwitch node. So we are going to have Open vSwitch rules program here. And if a virtual machine needs to talk with an external node, beyond our L3 out, then Open vSwitch already will encapsulate with the right network, the NAT network in this case, and send out the packet. So it will be still done in that model. And in that external, or the NAT network is going to be visible as a NAT EPG in ACI, if you will. So we're going to have all the SNATed IP addresses and the floating IP addresses listed there. So you can understand from an ACI view perspective to which virtual machine has been assigned, which floating IP, to which networks it belongs, what contracts I have for connectivity to the external world. right? And then DHCP DORA as well. DHCP optimization is done at the OFLEX agent directly, so you don't need to send traffic for DHCP to the network nodes. Metadata as well, optimization done in the same way, so on the node itself. Metadata does not need the VM to send the request to the neutral nodes. All clear until now? Yeah? Okay, good. One question.
The question is where and how the VMs are assigned to proper EPG, based on what attributes, what is the encapsulation and so on.
Yeah, so the question is how VMs will be assigned to which EPG. Bear in your question for 5 more minutes, and I'm sure it's going to be more clear. I have, it's going to be explained very shortly. One more question.
Yes, you capture the traffic packets between the virtual machines hosted inside of the OpenStack network between the two VMs. Do you have captures from the fabric to see what that looks like?
I'm sorry.
What would the fabric actually see as far as the virtual machines traffic? I know you had that in the UI, but do you have captures of the packets themselves just to see what the headers
So you mean sniffer trace?
Yes, something like that,
Yeah. So the question is, can you do a
No, I know you can do span traffic in the fabric. Do you have captures in your presentation?
If I have captures in my presentation, I may not have.
I just want to see what the headers look like.
Yeah.
The information. So.
Okay, the header you want to see. No, I don't think I have, but I can show you a bit later. So question was, do you have some will you show us some captures about what is the packet encapsulation sent there? I don't have, depending on the use case, VLAN or VXLAN, right? So this is going to be, but I can definitely maybe post something in the WebEx Teams. That's a good question, right? So if I've got sniffer traces between the host and the fabric of how the packet is encapsulated, I'll put something there. ML2 versus GBP. So many are wondering, what is this ML2? What is the GBP? So ML2, as I said before, is the Neutron API way of handling, your OpenStack system. So you keep doing the same way you were programming your OpenStack before. You create an OpenStack project, Neutron network, Neutron subnet, Neutron router, and so on, right? And in ACI, there's going to be a one-to-one mapping. So in ACI, when you configure a Neutron network and its subnet, basically it's going to be mapped to an EPG, the bridge domain, and the subnet underneath that bridge domain, right? And as well, router will be visible as contracts, security groups will be visible as we call host protection profile rules in ACI. So in ACI, you have a corresponding kind of object created for each and every component you have in your Neutron call. GBP is, as I said before, GBP is a project initiated by Cisco. It's an open source project which kind of can be consumed by OpenStack, any kind of OpenStack distribution, even if it is not bound to ACI. And it allows to basically create or abstract the application layer from the network layer. Why do I say so? So if you are a bit familiar with ACI, you can have one bridge domain, right, the routing domain, and then multiple endpoint groups, multiple groups of endpoints that can, by default, talk to each other. Well, with GBP, we try to do the same thing. So you're going to have GBP groups, which map to EPG, and then those GBP groups, potentially more than one, can map to a single L2 policy or an ACI bridge domain, right? So there is a level of abstraction there. So you have multiple groups of endpoints attached to one single routing layer. And then I can apply what is called policy rule set, which is nothing but an ACI contract. This policy rule set will be applied to a GBP group, right? So pair of GBP groups can talk to each other if there is a policy rule set allowing that communication. Something like this. So you've got groups with their BD, more than one maybe, so multiple EPGs, right? And then certain policy rule set. This is sort of provider EPG, contract, and consumer EPG. right? So that's the GBP model. Now, what is the best? GBP has, nice, interesting way of doing things. As I said, if you're interested in applying policy to group of endpoints rather than to the network itself, so you want to abstract a little bit the application from the networking concept, right? So GBP is quite interesting, and it maps directly one-to-one with ACI, what ACI is doing. Now, the challenge of GBP is that if you are using already RESTful API to program your OpenStack, then it may be a bit challenging to change your paradigm. So you need to change your API that you're using to program your OpenStack cluster. ML2 mode, the standard neutron API mode, is obviously you're keeping doing things as you were doing before, right? So you don't change the model. You have some automation, you're using Ansible, you're using some other scripts, some other orchestrator on top of Horizon, Heat, or CLI, then you keep doing exactly the same thing. You keep creating exactly the same type of objects, right? That's what you get. So you know what you get. It's the standard ML2 model. Is any one better than the other? I wouldn't say so. The good thing is that if you install unified plugin, we call it unified exactly because you can possibly create a subset of projects which are based on GBP. So you can use GBP, you can test it, you can try, you can have your GBP networks created there. And then maybe you can have other projects where you use ML2 model. So you keep using the Neutron APIs as you were doing before. So one single OpenStack cluster, you can use both GBP for some projects, ML2 for other projects. What is the limitation? You cannot use both GBP networks and ML2 networks in the same projects. So the question is, can you use that in the same ACI tenant? Well, an OpenStack project maps one-to-one with an ACI tenant. Before it used not to be the case, now it's the case. So when you create an OpenStack project, this will create one ACI tenant, right? It's a one-to-one mapping, you cannot influence that. Yeah? Demo time. Input 2. So let's see something live from my OpenStack installation. So I've got, in this case, it's a Red Hat platform. I'm running OSP 13 in this case, right? And it's just a plain installed system. So I've got the standard admin and service projects, which are running there. So in this case, I'm using 3.2.4. I have 3.2.4e as ACI version. So in the ACI, I can go in, do you hear me double, or it's just my impression? So I can go into my VMM domain, OpenStack, and I see, well, I've got multiple OpenStack installation, as you can see, right? I have visibility of my hypervisor, which are installed there. So in this case, I've got 2 compute nodes and 1 controller node. It's my installation. I have a view also of all the networks which I created in OpenStack. In this case, I've got none, because as I said, it's a new installation, right? And potentially, as soon as I start creating things, I can see for each compute node what would be the VM attached to that OpenStack node. I can see more information about the virtual machine and so on. So this is the global view of the whole OpenStack cluster that I have, right? Then I move to the tenants. So the tenants that are created there, we still see that there is no tenant but the default one, so admin and service are created there. Now, the tenant name is the project UUID in OpenStack. So we'll see that the tenant name in ACI is PRJ_ UUID of the tenant or the project that you created in ACI, in OpenStack. But we're going to have also an alias, right? An alias in ACI is something to make it simpler to find objects. right? So the alias will be the name of the project in OpenStack. Now, I will log into my under clouds. I could do it from the GUI, from Horizon GUI. I can do it from Heat. Anything is supported, right? But I like to run, little scripts, so it's easier to perform all the things together. So now what I've done, I wrote a little script. As you can see, it's a bash shell. What it's going to do is going to create a tenant, eventually to start creating networks into that tenant. So neutron net create 01, the subnet of the tenant, net 22, and so on, right? So we're going to have, at the end of the day, 2 networks and the number of virtual machine attached to those 2 networks, right? And effectively, actually, I'm going to provision also external connectivity, but that's something we still need to discuss. So let me start running demo 01, this shell script that I have. And while it is running, so it's creating objects, let's keep having a look at the ACI side. So from an ACI perspective, as soon as we call the first neutron call, this neutron call will enforce this ACI integration module to push RESTful API call to the ACI controller. So we see that a demo 01 has been created here, right? So it was a project non-existing before. Demo 01 is the name of the project, right? So the UUID is DF08, yada, yada, yada. That UUID long name. While things are being created, I can see already that I've got my 2 neutron networks. So the neutron network will be seen as EPG here. So net 01, net 22, they are there with their bridge domains, right? And now, obviously, while things keep being configured, I will see that in net 01, my virtual machine will be starting to be created. Obviously, it will take a few seconds before they're getting spawned and they load the operating system is 0, so it should be quite quick. But still, it will take a little while, right? So in here, I see already that I have visibility of, typically, there is a DHCP agent, an instance, which is provisioning DHCP to the virtual machine, right? So it's learned. It's running in the controller 0. This instance is running this IP address, right, which has been created by my subnet. The gateway for my network is actually configured as a bridge domain subnet in ACI, right, 12254. That's my gateway that is configured in ACI, right? And then I have here also a bunch of other information. What is the encapsulation? So someone was asking about the encapsulation that I'm using there. So I can see in the EPG, when the neutron network is created, automatically an encapsulation is assigned to that neutron network. In this case, it's VXLAN. It could be VLAN, right? So it's automatically assigned for me, transparently for me. And I will be able to see from an EPG perspective, the information about what encapsulation I'm using there under the EPG operational tab, right? So I have all these things. So net 22 also I should be able to see again the DHCP server. So shortly, the demo, the script is still keep going. So let me refresh. From an OpenStack perspective, I should be able to see shortly the Nova virtual machine spawned. So demo 01 obviously appears there. And I can probably log into the VM and just start a quick ping just to show that traffic is flowing throughout the different VM. So we see already, in the operational tab, I see VM1 and VM2 are visible. There is also a learning source here. So if you're familiar with ACI, you know that we have 2 ways of learning a virtual machine with a VMM integration. One is a VMM. That means from a control plane perspective, the AP controller and the OpenStack controller exchange information. I'm aware there is a new VM, but then there is also the learned thing, which means ACI lift switch has seen at least one packet from that virtual machine coming through the leaf. So it really means it's alive, right? So if you don't have one of those two things, you may already start thinking, okay, something is wrong, and maybe I need to troubleshoot, maybe there is something wrong in the connectivity, and so on and so forth, right? So the script has finished. I've got my things created, so I can console in one of the VM. I can see 4 are there. I will log in, a random one. So 22.7 should be my zeros VM. As soon as the console is available, I'll be able to start my pinging on some other device. Let me see if another one is more alive. Okay, while the console is loading, we can see indeed that I'm going to talk shortly about the L3 out. The L3 out will perform, if you want, SNAT or floating IP capabilities, right? So we're going to have these NAT endpoint groups, right? The endpoint group where we're going to present the external IP addresses that we use to face the outside world. So in this case, we're going to have 2 SNATed IPs, one per compute host that you have, because we are doing, obviously, with NAT, one-to-many. So all the virtual machine running in one compute node, they are using the same SNATing IP. If I assign a floating IP to virtual machines, then I will see also, the virtual machine floating IP address appearing in these endpoint groups. We see that the encapsulation is obviously different there. So we see that that's what it is. So zeros go, cubes go, and I'm able to log in. So what is my IP address? I have 22.11, right? So 22.11 is one VM. I can pin 22.7, right? So I can ping it right. 1.5, for example, that's another networks. So 1.5, I can ping, it's routing to another network where there is another virtual machine, potentially. Well, with my external connectivity and with the SNAT IP, I can ping also some IP address which is external to ACI, right? 71.101 is something running on a CSR 1KV, running attached to my ACI infrastructure behind an L3 out, right? So that's to show you, very briefly, how visibility and, the mapping works when I'm creating things, on one side, OpenStack, you have a very good visibility on the other side. So, PowerPoint. Let's go back. So that was the demo. So external network, how do you use external network? So external networks can be used in different ways. So one possibility is that you go for a shared L3 out. Why would you use a shared L3 out? Maybe you have got several OpenStack projects that want to, share just the same exit point. That's a possibility, right? So in this case, Pasta & Co. and Pizza & Co. with a lot of Italian fantasy are my 2 projects. And I want that they have connectivity in a shared manner. So one single L3 out shared by multiple projects. Or you can use a dedicated L3 out. Potentially you need to have specific L3 out extension per project that you're running for different reasons, right? So in that case, the dedicated L3 out is created per tenant. How do you do that? So the L3 out is a resource which you define manually, using RESTful API, let's say, or outside of the scope of the OpenStack plugin perspective. You define it in ACI, and then you consume it in OpenStack. So L3 out is already existing in OpenStack, in ACI, right? And what you need to configure is, if it is a VPC towards your external router, if it is some dynamic routing protocol enabled, all these things of an L3 out, right, should be there. and then you consume it from an OpenStack perspective. So let's have a view on how we consume it. To consume it in OpenStack, you just run a neutron net create command. It's a router external, so it's going to be an external router function, so something that you can bind as a default gateway to your router, to your neutron router, right? And you call the distinguished name. What is the distinguished name? The distinguished name is the identifier of an ACI object. So in this case, it's going to be your project name, your L3 out name, which is external net, and then the insp, which is the external EPG attached to the L3 out, so XDPG in my case. So by doing so, indeed, you you have an external network available in OpenStack that you can attach as a gateway to your router. So you just run, as you would do in a normal OpenStack installation, OpenStack router, you set the external gateway being your external network. That's what you do. When you define the external network, you also define one or two subnets typically. One subnet is normally used for SNAT. So as I showed you before, a SNAT subnet basically address one IP address for each compute node that you have, and then all the virtual machine attached to that compute node will consume the IP address of the compute node, right? So one IP for many virtual machines. Or the second one is a floating IP. So you can also add a second subnet, which will be used for floating IP, right? So that's external subnet FIP. How do you distinguish both? If you remember here, there was a small thingy called the epic SNAT host pool true, right? So that's defining it's a SNAT subnet. And in the other one, you don't do that, right? So that's a FIP. So you can basically then create your address per virtual machine that you create. You assign your FIP to a virtual machine that you have, right? So physically, that's on configuration perspective, that's the slide I was presenting before, right? So that's how it works. We create the NAT network also in the Open vSwitch perspective, right? And when the VM wants to talk with an external world, then it's gonna go indeed through the NAT network encapsulation rather than the other one. Let's see that more in details, right? How does that work practically? So I showed you before, the Open vSwitch indeed has two bridges when we are using OFlex. So one bridge is the BRINT, is the one running the security policy, and the other one is the one running more advanced kind of things, for example, NAT. Right? So this virtual machine, in this case, has been assigned with a floating IP address and wants to talk maybe with a client which is remote. It's behind my L3 out, is external to my ACI fabric. So how do we do that? Well, first of all, the endpoint files, you may remember that thingy I showed you before, right? The endpoint file running in this host is telling already all the information I need to know. So the IP address of my VM, the name of the VM, the metadata thingy, but as well the IP address, the floating IP that this machine should be using when it goes to the external world, and what is also the external network that I should be using, right? So the OVS has all the information it needs to do the right encapsulation thing. So with the packet will be generated, so destination MAC will be the bridge domain MAC address, so in this case is the typical gateway, the MAC address of my bridge domain, standard, or you can change it if you want. Source MAC is the source MAC of the VM. The destination, I want to reach this guy, and the source is my VM IP source, right? So what's going to happen is that Open vSwitch, you can check the rules. It has a rule that says, for this host, change the IP address to the other floating IP address, right? So the Open vSwitch is applying an OVS rule, which has been provisioned by the OFlex protocol in the manner we have seen before, in that nice long workflow that we have seen, right? So he knows exactly what to do. And, he knows exactly what to do, so it basically encapsulates the packet in the right external network, so it's already the NAT EPG, right, where the one where you're running the floating IP subnet. And it's obviously using destination IP, which is the same, but the source IP now is the, I think I copy-pasted wrongly, probably. So it's the source IP, which is the one from the OVS rule, or the floating IP assigned to that virtual machine, right? So how is that kind of visualized from an ACI standpoint? We're going to have sort of two different trees, right? So you're going to have one tree where you have your network where the virtual machine is bound to, right? So that's my net 01, net 101, right? The one that we were creating before. My virtual machine from OpenStack is attached here, right? And then from an ACI standpoint, ACI renders it like a connectivity to this is a sort of a dummy, a representation of an L3 out. In reality, this is just an OVS rule, so it's a representation of the OVS rules, which directly encapsulate when it gets the traffic into an external EPG, right, where you have got the external floating IP address assigned to the VM, and this will then route the traffic towards the L3 out. So that's, if you look at the view, the visibility of the topology of the contracts definition and EPG that you have, that's how we render in ACI the visibility of the traffic flowing between a VM and an outside world behind an L3 out with floating IP or SNAT enabled. So what if you want to run shared network? Very, very similar. Rather than being in the same, so before it was the same user tenant, in this case, it's going to be that the external EPG is going to be rendered in the common tenant, right? So the L3 out you create in the common tenant, and then you can consume by multiple OpenStack projects, right? So this could be one OpenStack project. You may have a second, a third one, multiple projects, which are all consuming the same, eventually the same SNAT pool, or you can create different SNAT pool if you will, but they will all rendered in an external EPG, right, in the common tenant. So that's the outside connectivity that is provisioned, and that's using the same L3 out connection. Yeah? Questions? Okay. I hope you got good amount of coffee before coming to this training. I know it was. No NAT is also possible. The trick with no NAT, again, I'll go a bit quickly through these slides, but you have these slides as reference. The trick for no NAT, you can do no NAT use case, but the L3 out must be in the same VRF where the OpenStack neutral network has been created, right? So by default, that's called default VRF. We also support what is called address scopes in Neutron, right? So with that address scope, you can define a different name for your VRF that you're using, right? But in any case, the L3 out must be in the same VRF where the neutron networks are, right? So that's the trick. And the second trick is that when you create the external neutron network, this time you pass this option, you say epic NAT type empty, right? So we don't want you to apply any NAT, right? And then OVS will just route the packet towards an external network, and that's all what it's doing, right? So there is no intermediate step of doing the NAT function in OVS. The packet is directly sent to the outside world, right? Of course, that's still a neutron network. It's an external network. So that's going to be set as the gateway for your router. That's what it is. Well, at the beginning of the session, I told you, well, you can, so OpenStack is one of the workloads that you can have, but this network policy framework in ACI can be shared across multiple different architecture workloads, potentially, right? So this morning we saw, for who was there, OpenShift integration, right? So OpenStack is another VMM integration that you can have. So if you want to have OpenStack workload and other workloads, how do you combine these two? How do you make possible the routing across virtual machine belonging to different kind of virtualization world, or even bare metal and maybe non-virtualized VMs? Well, the recommended way is to keep your so in this case, you've got your neutron network. So you've got O stands for OpenStack, right? So you've got your OpenStack domain attached to your neutron network, right? So you can create in ACI, the ACI administrator can create other networks for other type of workloads. For example, bare metal. It could be having bare metal and other type of virtual machine, for example, right? This is another endpoint groups. And you create a contract. So the ACI administrator will add a contract to allow connectivity from my OpenStack virtual machine and any other type of workloads which is existing and has been attached to the other endpoint group, right? So by doing so, basically, this enforcement of this contract is done from an ACI administrator. So it's not pushed to the OVS. So OVS will not know about it. But the enforcement will be done at the ACI top of the rack switch level. So effectively, how do we do that? Again, you've got the OpenStack admin creating your networks. We've done that before in the little demo that you have seen. So net01, subnet, the router. You attach the subnet to the interface, basic things. You probably create also some Nova VM boot and you attach to that networks. So you end up having this kind of scenario. Now, you want maybe those VM talking to a storage server, right? How do you do? Well, then you can bind, for example, this EPG database. You create this EPG database manually. So the Fabric admin, the ACI administrator, will create EPG database, will obviously create also the static binding probably for this guy, the FISDOM and all these nice things there. And we'll also create a contract, right, allowing maybe DB access for the right port between my virtual machine running in OpenStack and the storage network, right? So that's how you would extend the connectivity. And obviously, from an ACI standpoint, you will be having a visibility, a global visibility of all your workloads that you're having. So you see those as endpoints that are connected to each other. Right. Any question before the last topic before I relieve you for the afternoon? No? Okay. Hopefully all is clear then. No questions. That's good. So ACI plugin and DNS. It's quite often, and I was saying before, maybe telco use cases, 5G is very common, but also other use cases. You have maybe DNF. You have got functions from OpenStack perspective, load balancing function, IPS, firewall functions, right, that you implement in virtual machine in OpenStack, right? And you may want also those functions to be reachable from an outside world perspective, from an L3 out maybe. Now, what is the challenge there? Typically, when you've got VNF, you may want to have those VNF exposing services. Maybe it's a load balancer that exposes VIP addresses, and then behind it as a server farm But you may want also to have multiple VNF instances, right, that expose the same service, so you can load balance across those VNF, right? And maybe those VNF also want to have some sort of dynamic routing protocol, maybe BGP, so they can expose service dynamically. I create a new service and already it's well known by the outside world. How do I do this, right? And how do I do this also dynamically? I shrink and I increase the number of VNF that I have. Well, that's possible with what we call the neutron SVI function for the ACI unified plugin, right? So the neutron SVI function is basically a feature that allows the dynamic creation of an L3 SVI based on where you create your virtual machine. So you create VNF 1, 2, 3, 4, right? Each time you create one of those, ACI will dynamically create SVI because it knows exactly where the VNF is, and it will start peering, if you require to, BGP with the autonomous system number that you define there. Not only, but ACI will be capable of doing up to 64-way ECMP load balancing if you are doing BGP between the VNF and ACI. So imagine you can grow up to 64 VNF there. You have 64 VNF, and they all expose the same service. Well, ACI, each client which wants to talk with that service will load balance per flow the traffic using ECMP towards the right VNF, right? So it will do a ECMP round-robin load balance towards different VNF. By the way, you also keep track of VNF which are dying, so we have some kind of basic probing mechanism. So if the VNF dies, we remove from the hashing algorithm, and then we rebalance the flow towards the other VNF existing, right? How you do that practically? So you've got, again, you just use neutron calls. So you've got some neutron commands where you pass some more parameters. You will say, this neutron network is a bit special one, right? Because it's a NAPIC BGP enable, it's a NAPIC SVI true, right? So you say this guy is actually an L3 out. So when you do this command, an L3 out will be created for you, right? LB SVI, I didn't do it manually. This time it was created from the plugin directly. Then you assign also the port, so you can say, each leaf has a static IP. Why would you have that? Because if you need to do some dynamic routing protocol, you want the VNF maybe to know to which peer they want to have dynamic protocol routing to, right? So you can, if you will, assign static IP to the leaf switches, and then you pass by the creation of a neutron port, right? So that will assign IP addresses to your leaf, to your physical leaf. And then finally, obviously, you can create, for example, in this case, I had some load balancer I wanted to plug into my L3 out. So you create a neutron port there with a fixed IP, and then you spawn your load balancer image, and you bind to that neutron port. Right? And that's how, indeed, we allow that load balancing mechanism. So L3 out here will reach, will be load balanced to a different leaf component, and then from the leaf, eventually will load balance to a VNF, and that, again, can keep increasing or decreasing depending on your demand that you are having. Yeah, that's cool. Yeah. Well, want to know more? WebEx team. So you find me in WebEx team. There is obviously you can ask me questions. I'll be around for the next several days. You can send me email. You have obviously also some documentation online. I'll be also here for a few more minutes. So if you've got questions or you want still to ask me, I think we've got 5 minutes left here. So I'll be around. And yeah, please feel free also to follow up with the survey and let me know also your feedback there if you want to put some comments about was their session what I was expecting, or I want to know more about this or that. I want to have some sniffer capture like you know, the gentleman of before. I'll be glad also to change things for the next presentation. But thanks a lot for your patience, for being with me this afternoon. Thank you.